With Johnson Controls. Today we're going to do the software portion of the training for the Salt Lake Community College Instruction Administration building. So first we'll kind of show it. This is your building dashboard, which is designed to give you just a quick overview of the way the whole building is running, and it allows you to get a quick glance to see if you see anything that's any potential issues. To start through, this is your outside air temperature and humidity sensor. This is located on the building as we discussed last time, and this is the one outside air temperature and humidity for the building, so it is shared globally throughout the different processes. Down here you have your relief fans. You can see right here where it's spinning, that means it's on. This is stationary in red, so it's off. Then you have your exhaust fans, hydrogen sensor in the mailroom. And these are all your primary systems, which gives you just a quick glance so you can look at what your discharge air temperatures from your air handlers are doing, what your hot water heat exchanger is doing, domestic water, and so forth. Going up to the building overview, we've tried to put these little blocks according to the different floors. And what they do is they'll take you to a link to the individual floor plans. But each one of these boxes indicates something. Say, for example, this one's red, which means that there's one box on this level that's in an alarm. The next one is a warning, and the next one is offline. So it gives you a quick glance to say that, oh, I have 6 alarms, or I got boxes offline, or whatnot. From here, we'll just kind of start up here on one of the levels here. Click on the button, then it takes you to a quick overview of where all the different boxes are, or different zones. And you'll see that everything has a different color. If I hover over it, you see how it changes to a dark, which indicates the zone that VAV is actually serving. So even though all these are blue, you can see how they highlight because one VAV box is serving multiple rooms. From here, you can see the different colors, and you're going to see that the blue means that they're cool, that they're below set point. Red means that they're above set point. Yellow means that they're approaching a warning, and the gray, I believe, is well, it's just not there. If it was gray, it would be unoccupied. When you look at this, even though you see a lot of color here, that doesn't necessarily mean there's issues. I mean, the boxes are always going to be heating or cooling, so it's kind of typical. The only way that they're going to be white is if they're satisfied, if they're within their deadband. From here, you can simply click on one of the boxes. You press it once, and it brings up this little indicator here. Choose another quick indication of what your zone temperature is, your zone set point, occupancy status, box mode, whether it's in heating, cooling, or satisfied, and then your effective cooling and heating set points. Looking at this scale here, it'll give you an indication of where you're at within before you approach any alarm limits or warning limits. So, excuse me, as you get either below set point or above this, so what is that, 76 or below 66, you'll actually go into a warning, which means, hey, something's getting a little out of whack here. If you keep going down further into the red, on this one it's 50 or above 90, you'll actually go into an alarm condition, which will actually pop up a notification letting you know that you're in an alarm. A quick thing to note when you're looking at one of these boxes is when you're looking at a zone, it's real important that you're looking at the effective cooling and effective heating set points when you determine if there's something actually wrong. The way that the zone set point works is that it takes this right here. You guys familiar? We talked about this already? A little bit. Yeah. So the zone set point is what's indicated on the dial. There's a 4-degree dead band in between these two. So it's going to take 2 away from the below and add 2 to it. So here you're going to be, what, 69 and 73, which is what the effective cooling set point is. So as long as I'm in this, I'm actually satisfied. Your first glance, you look at it, says it's 70 degrees, but your zone set point is 71. You might think that something's wrong. Well, actually, you're well within your dead band, so you're just blowing minimum ventilation into the space. If you click on one of the boxes again, or double click on it, it'll actually take you into the graphic for the VAV box. Here we've given you a little bit more parameters so you can actually help to diagnose or look at what's going on with some of the boxes. You can see this is an office, looks like it's unoccupied, or has a minimum ventilation of 0. Occupancy status, not populating yet. So the damper position is actually closed with it. You can look at the discharge air temperature from the air handler. So we separated these into air handler 1 and air handler 2, so you can see what's coming into it and what's leaving, which helps to troubleshoot as far as your, if you had actually hot water flowing through the coil or whatnot. This one has a radiant valve as well, tied to the radiant heater. From here, as you guys probably already know, there's a couple of cool things you can do. One, you can look at, you can make a command. So if you click on one of these boxes right here, right click, you can hit more commands, which will give you the ability to make adjustments. One thing I would always recommend doing is whenever you're changing something, always do an operator override if at all possible. That way it gives you a quick ability to look, to run a report and see what was what was overridden, and just helps keep things simple. So if we override it here, we'll just go to 25%. You'll see that this is going to go orange here. That means that you have an operator override on this point. When I right click, hit more commands and hit release operator override, it'll now go back to white, letting you know that it's back in normal control. From here, you can also look at trends. Let's see, I don't know which one. Here's one right here that has the trends on the heating output. Same thing, if you just right click on it, you can hit view trend. And it's going to give you whatever's in the repository. So generally you'll get about 24 hours worth of trends here. It allows you to look at a snapshot of. We've done them every 15 minutes. You can look at them that way. Another cool feature that you have the ability to do is also to overlay additional trends on it. So I've looked at the one, and now if I just grab another one, we'll just look at temperature. Now you see that it's added another one overlaid on top of it. I can either hide it or add it, but it gives you just another ability to kind of troubleshoot the points in the same reference of time. And if I just want the one trend back up, I just remove trend and we're good to go. So this will allow whatever is physically inside the NAE before it dumps to the repository, you can look at it through the trend viewer this way. Anything past it, you can still use a trend study or use a trend viewer to actually pull trends from the server. And these, it only stays in this buffer right here while you're on that graphic. As soon as you go away, it clears that buffer. From here, you have these drop-down boxes, so you can see a little arrow here, and these ones you can actually shrink down as well if you wanted to. But from here, we open them, and it gives you just real quickly some common things that you might want to potentially adjust.
When you minimize those, is it user specific?
And actually, when we set up the graphic, we can set so when you first look at it, whether it's open or closed. But after that, it'll go every time you open it. It's whatever we set it at, either to be open or closed. And so, if I close all these and I go away from the page and I come back to it, they'll all be open again. So, but if there's certain points that hey, I like it on the graphic, but I don't want to see it, we can, like I said, we can shrink it down. So looking at these commands and statuses, a couple of the quick things that we're kind of looking at here is one is the heating enable. That one's not quite as important here, but it has potential because you do have a heating max. If we don't have heating available, like you've disabled the heat exchanger or whatnot, we have it set up so if we don't have hot water, we actually disable the heating enable. So that way, if the box is trying to heat, it doesn't blow more air into space trying to heat something, even though it's actually cooling the space. So that's kind of something to kind of watch for. You shouldn't have to do anything with it. It should automatically take care of itself. It's just something, if you're looking at it and say, why isn't it heating? You might want to make sure that your heating enable is set to true. Here you can have cooling max flow, cooling occ min, on-occ min. Same type of thing with all these points. You can right click on them, hit more commands, and change the values on them. The flow set points, as we kind of mentioned before, is your cooling max. When your cooling occupied min flow is the minimum flow set point. Whenever the box is satisfied that it blows, it then resets it as a goes off temperature up to the cooling max flow. And the same thing with the heating. So you have a heating min flow and then a heating max flow. And then your occupied schedule here, right here as well.
Does the occupancy of the VAVs control the occupancy for the air handler? Or does the air handler have its own schedule?
And that's something that we'll need to talk to. Right now, we haven't put any schedules in or implemented any schedules, so we'll need to see how you guys want to run that. but generally there'll be one schedule that does the air handler and the VAVs, so we'll schedule everything. If we just schedule the air handler, the issue with that is the VAV doesn't know that it's off, and so its dampers are wide open and all that kind of stuff. So we try and schedule both things. The VAV box does have the ability to turn on the air handler if needed, but generally be one schedule that does both. The other thing too is we can also, if we need to break it down, say the offices are 8 to 5, but the classrooms are 7 to 10. We can create different schedules so the offices shut down earlier, stuff like that. So we just need to talk about how you guys want to have that set up. So I guess real quickly why we're here, this might be a good point to talk about some of the sequencing with these VAVs. We kind of mentioned it before when we were walking through, but a key thing with these boxes, so cooling is pretty standard. So you're trying to maintain the temperatures. The further away you get from your temperature, you get warmer. The VAV damper is going to open up more and more up to the maximum cooling set point to provide that cool 55, 50 degree air into the space. Heating's a little bit different. Heating, we're trying to, the box goes into heating mode, so when we go below set point, the first thing it's going to do is it's going to try and open up the heating valve to maintain a discharge air set point. Right now it's reading 0 because it's satisfied, but when it actually goes to heating mode, that'll go and it'll reset, I believe, between 55 and 85 degrees. Your first stage of heating is we're going to start modulating this heating valve to maintain a discharge air set point. Once that PID gets up to over 50%, we're still below set point, we then reset the airflow set point between the heating min and the heating max. So a couple of things to note is that when you're looking at it and you're, say, first thing in the morning, or for whatever reason it's really cold in that room, why isn't my heating valve open? Well, we're trying to maintain discharge air temperature. That heating valve does not control to maintain zone temperature. And the logic kind of behind that is if you have really hot water and you're dumping that into the space, that hot air rises, and so it just stays at the surface and it floats on the ceiling and gets sucked out for the return. Where if you provide a little bit colder air, it actually mixes into the room a lot better and it's a lot more efficient that way. So, something to kind of make note of. So from here, we'll go back to the home page. If we click on the home here.
Are you able to override the valves, the reheat valve,
Sure.
or the coil valve?
Yep. Just same thing, just write more commands and do it that way. I guess real quickly, a good point is this right here, this just takes you to the physical point. You guys are kind of familiar with that, I'm sure, where you can modify the trend values, look at the trends a different way, change the definition of how much trend data you're holding into, that type of stuff. One other quick thing too. So this heating, as this heating valve opens up, this coil does animate, so it does go up and down, so you can see it. I believe this damper actually moves as well, so you'll see the damper open and close as well. So that's pretty typical with all the different floors. From here, it gives you a quick little layout of where you're at within the building, whether the center, different floors. Keep going down here. So with your relief fans, there's two different sets of relief fans, and so you have the lobby set and then the atrium set. The atrium has 3 exhaust fans tied to it, and they all run together. So what we're trying to do is you're going to have the 2 sides of the building. The lobby is the west side, and the atrium is the big open area. So you have an atrium set point, and then you also have a lobby set point. And ideally, you'd want to keep the set points about the same. You don't want to get them too far, and we can create a general building pressure set point if you want, if it becomes an issue. You just don't want to have 0.08 inches here, you create a kind of a wind tunnel. But there is 2 different systems for the relief fans, but these all will modulate together. The way this works is when the air handler that's associated with this area, which I believe is air handler 1, whenever that's running, we enable the relief fan system that has the ability to run. The first stage is going to modulate the dampers up and down to maintain its set point. Once these dampers become fully open, 100% open for, I believe it's about, right here, fan delay is 5 minutes, it'll then enable the relief fans to turn on. The relief fans will then turn on and modulate up and down together with that. Real basic. Down here you have a system enable if you just need to shut it down, operate override that faults. AHU is on. That's the link from the air handler letting you know that the air handler is running, so the fan system is enabled. And then you have your damper to fan on delay and your fan to damper on delay. These are just your transition points from when we turn the fans on and off. So 1, 2, and 5 are tied to the atrium, and then on the other one, the lobby, is the other 2. This is one we kind of talked about a little bit before, but it's, I don't know why the fan's still off. I'm going to address that. Do you know what?
It's been reported.
Okay. Keep going down. The mail cart room, we kind of talked about that.
Okay. Yeah, and it didn't stay, it went back off. Somebody's turning it on. And that's probably your alarm on your second floor there, your middle
Right here.
yard there.
Yeah.
Probably that.
Do you worry about any of these alarms, or?
It's one of those signs.
Yeah, most of them are from the other camp.
Okay. So here's a link to all your exhaust fans right here. So the biggest ones you're going to have an east and a west exhaust fans 1 and 2. These exhaust fans right here will basically just be on a schedule, so whenever the building's occupied, they run. If the building's unoccupied, they shut down. Yeah, the mailroom exhaust fan here, this is the one in that cart charging room here. Ideally, this fan will always be off. What will happen is if the hydrogen gets too high in that room due to the battery being charged in that car, it releases some hydrogen. If it gets too high, you'll actually get a buzzer in that room going off, and then it'll enable that, excuse me, that exhaust fan to turn on. You'll also get an alarm notifying you that, hey, something's going on there. These two rooms right here, they were quite a question on what they were doing with it, so we'll probably need to modify that. They changed that AV closet layout from where it originally was, so these will be modified a hair. Going down here, so here's your chilled water system right here. Chilled water system's real basic. One thing that we do need to kind of fine tune is when we enable this system to run, but right now the way that it's set up is whenever there's a call for cooling from the air handlers, we enable the chilled water system to run. We're getting chilled water from the main central plant, and these are just simply pumps that pump it throughout the building. We do have temperature sensors and flow sensors that'll provide some BTU measurements for you, some calculations, but they're not used for controlling purposes. We're just dumping water out to the space. You'll also have coil temperatures across your coils, so you can kind of get an idea of what your delta T is across those coils.
Where's the BTU meter for chilled water?
He's got a link right here to it. Do you want to know physically or on the screen?
On the screen.
Okay. Yeah, he's got a little link to it.
Is that for both? Yeah.
Yeah. There's another one that we probably ought to add that gives you the ability to totalize and reset and all that kind of stuff. Your energy guy will probably want to know about that. We'll put a link on here to how to reset it. What he has there is just instantaneous values, which probably are good, but not what you're looking for. A couple of things with the pumps to note. So here we have command, output, and amps. So instead of just a status, we're actually looking at the current draw of the VFDs. When this does turn on, it will give you status. It'll start spinning here, letting you know that it is running. But what we're looking for is actually the current draw of it. And so we've determined what the minimum current draw is when that fan runs. It's actually a kind of a nice way of doing it, because that way if, you know, if a couple breaks or something like that, it's just free will, and you're not gonna get status because you're not pulling enough amps. A lot of times on a switch, if it's not adjusted quite right, you'll still show a status. So when this turns on, you will get a status, it will have a spinning wheel, but you're gonna get a current draw through it as well. This just, when the system's enabled, the pumps turn on, and we just control to maintain a differential pressure.
Those pumps are in parallel, not series, right?
Yes. Yeah. Yes. Cooling tower right here. Indirect tower, this is the dedicated tower out at the building that just serves those 2 air handlers. So whenever there's a call for the system to run, it enables the fans and everything to turn on and run. A couple of things here. So you do the same thing with these pumps here. Filter command. So here you have the 2 pumps. You have the solid separator, or cooling tower filter, whatever you want to call it. Whenever either one of the condenser water pumps are on, that solid separator is also enabled to run as well. Whenever the pump shut off, the solid separator disables as well. For the cooling tower, we're trying to maintain a condenser water supply temperature of about 50 degrees, this one right here. So when we turn this on, these are just constant volume pumps, they run, the cooling tower fan then modulates up and down to maintain a condenser water temperature. Same thing, you also have a current draw here. There's a level sensor here that gives you the ability to read what the level of the tower is, but it's not a controlling sensor. We're using it for monitoring and alarming, but not for actually controlling the level. That's all done through the float inside the base of the tower. We have a basin temperature of 4 right here. That's just the temperature inside the basin, as well as a vibration alarm. The basin temperature, the way that that works is that whenever there's water in the tower, and if your basin temperature gets below, I believe it's 35 degrees, for more than like 5 hours, it'll set off an alarm letting you know. If there's no water in the tower, it's not going to give you an alarm. So it's just an indication that, uh-oh, we forgot to drain the tower or whatnot.
Is that based off its level?
It is. So there's a minimum level. As long as there's, I think like if there's at least 2 or 3 inches of water in there and it gets too cold, it'll set off the alarm. If if you're going to have a little bit on the bottom, it's not much you can do about that. We also have a makeup meter. Not sure why that's question marks, but there's a makeup meter. All of that's just is totalizing how much flow you're dumping in, how much water you're putting in that cooling tower, lets you know for energy, for water usage.
The water dumped to the sewage, or the water dumped to the storage tank?
The water dumps, this meter, excuse me, is in the line that feeds the cooling tower. So it's actually located in the space, but it's in the line that feeds off the float valve. Is that your question?
Makeup valve.
No, I mean, when we have like cold temperature, we dump the water in the drain, in the sewage, or we have some storage tank.
It dumps into the sewer, basically.
Okay.
And that's another good point we kind of mentioned before is that is not an automated process. That does need to be done manually. So I don't know if there's water. Well, if there is water in it now, I mean it's supposed to get pretty cold over the weekend. That's something that you might want actually to dump the system. So.
You can change that to an automatic valve and just come over here and put a dump in it.
We brought that question up. There is a drain valve there that we could tie it. It's not tied to any programming now, but there is a drain valve. But the issue is there's no makeup valve. It'd be somewhat easy for you guys to add a valve to the makeup system, but you would, due to the way that the piping is, you would need to heat trace that line going up there so you don't freeze that copper line that actually feeds the tower up above. But it would be pretty easy to add that control if needed.
It should really probably been put on just have a temperature, outdoor temperature sensor.
Yeah.
Shut off your makeup and then dump.
We've done that before in the past. I'm not sure what the reason for not having it is. I'm not sure. Now, some of the concerns is you get through these spells where it's really warm in the day and then cold at night, and you're constantly dumping and filling and that type of stuff. But definitely a possibility to add that. Here you have your 2 air handlers, air handler 1, air handler 2. As far as controllability and everything, they're completely identical. The really only difference is Air handler 2 is a bigger fan, which has more of a fan wall with 6 fans, 2 VFDs. Air handler 1, just one really big fan. On here. So as we kind of mentioned, you know, kind of talking about before, there is quite a bit of stuff going on here, but there's a lot of good stuff to look at. So if we just look at the top, the way that this is set up is you have your return air coming in this way, goes down through your return air damper. You have your outside air here, and right here is where it's mixing in between, and it goes through all your coils. So looking at your sensors, excuse me, you have your return air temperature, return air humidity. Return air temperature, that's just a monitoring point. We're not using it for switching over between economizer and whatnot. That's all done off outside air temperature and state and dry bulb. Return air humidity, that is a sensor that if your return air humidity gets too high and we're running the evaporative media, that will disable the system, the evap media from running. Keep going down here, you have your return air CO2. Return air CO2, that has the ability, if your return air CO2 gets above, I believe, 800, we will slowly start resetting our minimum outside air flow set point up. I believe it resets it in 10% increments until it eventually gets to the maximum set point. So if your return air CO2 gets too high, you will have a potential to reset that maximum outside air to 100% outside air. Coming down, return air damper here, outside air damper here. 2 separate signals, but they run together, just inversely. So as this one's 12%, this one's 88%. They just work opposite of each other. Here you have your outside air flow, reading, and your set point. That set point, as I mentioned, will reset based off of CO2 position. Otherwise, it just has a fixed minimum outside airflow set point. These air handlers, a good portion of the year, will be running in 100% outside air mode. The only time we're not running in 100% outside air generally is when we're in economizer mode. Going through here you have your filter. This one right here is set to a switch. It's set to an alarm, but it also actually reads the filter differential pressure. This is one that he's collapsed, so when you first look at it, it's just collapsed. If it goes into an alarm, it'll turn red. Otherwise, if you wanted to expand it, you can look at it and see what your actual pressure drop across the filter is. Going through, you have your mixed air temperature and your set point right here. Going through preheat temperature. The preheat system right here, whenever we call for the preheat to run, we turn on the pump. The pump runs the water through the coil. The heat exchanger valve right here modulates. So this is the glycol side. This is just from your heating system here. Going down, you have a preheat temperature. This is this sensor right here isn't used so much for controlling, but it is used as a pre-safety device. If your temperature gets too cold after this coil here, we will automatically override these dampers shut. So we have a low set point, I believe between 44 and 36 degrees, that if our preheat gets below there, we automatically override the dampers the other way, because something's not right if we're getting that cold, just to help prevent the freeze staff from tripping. But it is just a software point, but it is there to, in the last resort, you might see your dampers going opposite if the sensor gets too cold. Going through, you have your low temperature alarm, you do the same thing, it's just shrunk down. If it's red, it means it's an alarm. Excuse me. I believe there's 4 of these sensors for each air handler, so if any one of them trips, it will shut the whole fan system down. It is a manual reset, and it is a hard safety, so there's no overriding it in the system. You physically have to go and press the button. Here you have your 2 fans. From here you have the ability, I'll explain this in a little bit more detail, but to either bypass the coil sections and go up and around out to the building, or to feed through the coil section. The only time that this damper is in action is when we're running the evaporative media mode. Here, indirect valve coming from your cooling tower. These temperature sensors here, indirect and cooling temperature, they're there for monitoring purposes, not so much of a controllability, just gives you the ability to look at what your temperature drop across the coils is. Going down here, there's a few more things involved, so it looks like he's created a separate link to it, but here's your, so if you click on this, it'll open up the window for your evap stuff. This is all, we kind of mentioned this before, but it's all an automated process. But here you have your flush command, fill command, drain command, and then your evap pump on and off. Go down, discharge air high static alarm here. That one's set, I believe they're both set at 5 inches, and these are also a manual reset as well. Going up, discharge air humidity. This is a sensor that's not used for control, it's just for monitoring purposes. Please note that, you know, when you're running an evap media, that can be a very high number. Don't get too concerned about it, but, you know, the colder air and the more humid, you know, it kind of goes up. Evaporative air temperature, that's right here. I guess a good point, this right here is just a monitoring sensor right here, just lets you know what's coming out from the evap media. Your controlling sensor is right here, it's after the 2 ducts combine. So, and the reason why we do that is because there's a potential why this is modulating up and down. This is what's going out to the space. This is the sensor that we truly care about and want to maintain its set point. This is your discharge air pressure right here. This does, if I remember right, this does reset off of VAV damper position. So as your dampers open and closed, that set point will go up and down. I believe, I have to say, I believe the minimum is like 1.75 up to 1.75, somewhere around there. But they will modulate up and down. We're trying to maintain your damper positions to have no dampers greater than 90% open. But trying to save energy as much as we can. Here are your fans, 2 different fans, but there is 2 different fans, 2 different outputs, but they both receive the same signal. Same thing with these ones. We are, since it is on a VFD, we are measuring current draw through these fans. Here we have the set point block. Gives you the ability to look at quite a few things. Effective occupancy schedule. Here's your minimum. So they've set them both at 1.5 right now. Here's your outside airflow set points, min and max. Discharge air temperature sensor resets, min and max. These are just all your different ability to adjust these set points. I guess we'll go through some of these real quickly. The way this air handler works is there's 5 different cooling modes. Before I get started on this, you guys have any questions with this? Okay. The way this air handler works is there's 5 different cooling states. So the first state is going to be state 1, which is called preheat. So that's when we're cold outside. When the air handler first starts up, it's going to look at what the outside air temperature is. If we're below 45 degrees, we're automatically going to start in state 1, which means we allow the preheat to run. And if the preheat valve stays closed for more than 15 minutes, we automatically go to state 2, which is economizer, which is the state that we're in right now. Economizer is just going to make open up the dampers, open and close to modulate them until your outside air temperature gets above your mixed air temperature set point, and then it'll jump to the next state. In this mode, in state 2, we're controlling the mixed air dampers to the mixed air temperature sensor right here. So we're not relying on this discharge air temperature sensor, we're relying on the mixed air sensor right here. So that'll go up and down. This set point resets off discharge air temperature, off outside air temperature. And you can see here, so you have a minimum outside air reset between 40 and the max is 55. We'll reset your discharge air temperature between 47 degrees and 54 degrees. So your mixed air temperature has the ability of going all on a really warm day, it'll be trying to maintain a 47 degree, and as it gets colder, it raises up your set point to 54 degrees. So when the outside air temperature gets above whatever that floating set point is, we will then switch to, depending on if it's available, state 3, which would be your evap media. Your evap media would then go, and the first thing we would do is we would shut the drain valve, open up the fill command, and leave the flush command closed. That'll run that way for about 15 minutes while we fill the pan up. After that, the evap pump will turn on. We've got a status on, and then now we're making these dampers at 100% open, air's coming through, and we're now wetting the pads and blowing that cold air through the evaporative media. We then will modulate to maintain temperature using this. If it gets too cold, we open and close this damper right here to allow air to either go through the evap media or it actually go up and around to bypass that evap media there. So this is where the control of this damper comes into effect. So you shouldn't get those really big temperature swings between, 60 degrees shouldn't evap media on, it drops 20 degrees. It should be a very gradual, smooth. You should have a lot of controllability doing it this way. We then stay in that mode. We have a minimum runtime of 60 minutes in that, because once you turn that evap media on, it's not instantaneous. It's going to take a little bit for those pads to get wet. The more they get wet, the better they work. After an hour, if we're still above set point, so from here, here's your mixer temperature set point. Evap media has a 2 degrees above there. So if we're 2 degrees above our set point, and you'll see where it'll all change right here. If we're above our set point, we then switch to the next state, which is state 4, which would be your indirect coil. Your indirect coil will then modulate up and down to maintain temperature. Your evap media in that mode actually stays 100% open. Fully on. This damper would be closed, and we're using the indirect coil now to maintain temperature up and down. From there, if we're still above set point after, this one has a 30-minute run time. If we're still above set point, we then call for the direct or mechanical cooling, which will then allow the chilled water system to modulate, I jumped coils, the chilled water system to run right here. This one, from here, indirect coil is fully open, evap coils, or evap media is running, and this is your controlling sensor right here to maintain this discharge air temperature. To go down the other way, when this cooling valve gets below 5% open, we then will switch to state 4, which goes back to this coil. When this coil is open less than 5%, we then switch back to state 3. So now we're controlling out this bypass. We then will stay in that mode until the outside air temperature is below what our mixed air set point is, which will then switch back to economizer, which is state 2. Which will then stay in that mode until we're below set point, which will then go to preheat mode right here. Kind of a real quick overview of how this air handler goes up and down. A couple key things you'll see in this point. There's something called an evap lockout right here, which is set to true. What that means is that there's a couple things. If you don't want the evap media to run, say it's going to be really humid outside, it's going to start raining or something like that, I don't even want it to run. If you turn that evap lockout to true, it'll skip the state. Instead of going 2, 3, 4, it'll go from 2 to 4, from 4 to 2. It'll just skip over that. You also have the ability, so return humidity lockout set point is 50%. So we're running, all of a sudden it got about 50%, our humidity got too high in the return. We then, I'm done, skip the state, go to state 4. On its way back, it's just going to skip over that state as well. Your effective evap lockout is really, that's not the command point, that's just your effective state. That's letting you know really what it's doing. Let's see. Any questions? I know that was a lot to jumble over. Okay. Here. Here's your hot water system right here. You can see right here that it's running, moving hot water through the coils. Click on this. You have 2 different heat exchangers. So whenever the system's enabled, the steam isolation valve opens up, which allows hot water to flow to either one of these heat exchangers. This isolation valve right here is set so whenever the system's disabled, it'll automatically close, or if somebody was to, an emergency, hit the brake glass button, it'll spring return close and shut down. The way the heat exchanger works is we're basically using it as a lead lag, and so as we're trying to use one heat exchanger, if this was to get above 100%, which means this valve's fully open, we would then call for the second heat exchanger to run to modulate to maintain our temperature set point. Going out of here, these are just for monitoring purposes, what your leaving temperatures are coming out of the heat exchangers. This is your high temperature alarm that we talked about in the building, where it's a manual reset up high. It's set up, I believe, 200 degrees, so if something goes haywire and this trips, it is a manual reset, and it does mechanically force these valves. loses power to them, and they will force shut. Pumps right here. These pumps will run together quite a bit of the time. It looks like that's what they're doing now. These pumps are controlling to maintain differential pressure set point. It looks like it's 18 pounds. As that goes up and down, if your pump gets above, I'd have to look at it. I thought it was 70%. We'll call for lag pump. When it gets below 35%, the lag pump will drop off. Here we're trying to maintain, looks like just 120 right now. This does reset based off outside air temperature. This right here, hot water supply temperature, is your controlling sensor for these heat exchangers. Through your coils, this is your DP. Hot water DP is located on the 3rd floor. I'll show it on our as-built, but that's the location of the hot water DP. Position of emergency stop, and this is just your return, lets you know what kind of load you have out in the building. You have about a 10-degree load across it. Also have a link to your BTU meter as well. Here's your set points. Your pumps automatically rotate, but if you want to rotate the pumps, you can just hit the right click and hit rotate. You can look at your run times of your pumps right here, both about the same. The way this works is, and we kind of mentioned it before, every time the system goes to turn on, it's automatically going to rotate whatever pump has the lowest run time to run that. If the system went hot water, we're probably going to run all the time. If they do have the potential, if we don't rotate them, that the one will always run, the other one won't get any run time. So that's why we do try and rotate them. I don't remember exactly the time, I'll look at that.
Do we have the same thing on the heat exchangers? I don't want the same heat exchanger as lead all the time.
Very good point. No, I'd have to look at that. That's a good point. I think we do.
When we have the PRV, was pop-up, and we're talking about the pressure relief valves. The guy said they are working together, don't have secondary and primary. They works together. Now you say this is secondary.
Both heat exchangers?
Yeah, the PRV.
Oh, the PRV, they both work together, but the heat exchangers are separate.
Okay.
I'm assuming that's what he was talking about, was probably the PRVs. Those both run together. All right, here we look at the domestic hot water system real quickly. Domestic hot water is fed off of those heat exchangers in that building, so that's why you pretty much need to leave those running. We talked about it a little bit with Daniel. I would almost say you'd want to leave that running, the heat exchanger running all the time. You're going to have classes till probably 10, 11 o'clock at night. You start up again at 5, doesn't give you a lot of time to really do much, and then you have to recuperate all the water in that tank. So I'd probably just allow the system to run. Whenever the system runs, we enable the pumps. Here you're pulling from the heat exchanger, and you have a hot water valve here that modulates to maintain 110 degrees going into that tank. So this valve right here modulates open and close to maintain this temperature. This then dumps it into the tank, and then you have your recirc pump kind of circulates throughout the building. You do have the ability to disable the whole system right here. Just right click, hit off, and it'll disable the system from running. But other than that, real basic setup. All these pumps will run together because this is what pulls it through the heat exchanger. This is what pumps it into the tank, and this is your recirc pump out to the building. From here, we also got a couple other things. We do have some basement room temperatures here. We didn't do a graphic. I don't think you were part of the original walkthrough, but we do have some critical rooms, especially in some of these basements. So we have the west elevator room, west comm room, east emergency room. These right here are temperatures of those rooms. Those rooms are primary cooling. They have fan coils in them. They're fed off house air. As they need additional cooling, they do have standalone fan coils to come on to maintain that temperature. One of the things we were talking about with Daniel is those fan coils, they do rely off building chilled water. And so if we shut the air handler off at night, we need to make sure that we have the potential to have chilled water to feed those, feed some of those rooms.
Which I don't see how you're going to have that.
Yeah, we'll have to come up with the best way of.
Which means to run a chiller.
Yeah. I guess that's kind of a real, kind of a brief overview of the way all the systems run. All of our as-built will have the, an actual schematics you kind of read through and follow how it's working. We're also available, you always call me, I'll leave some cards or something if you have questions about how something's working or why something's doing what it's doing. Any other questions that you have that you want to go over now, or if we're done with him, we can kind of discuss a couple things in specific, but any that jumps out at you?
Nothing we haven't
Okay.
just talked about.
So a couple of things that I do want to make sure we address, and I don't think we need to get on tape, but we just need to talk about what alarms you want to get paged out on. Right now, I don't have any alarms set to email you guys. Everything's in the system, but I need to change those to email you guys.
Yeah.
We can talk about some scheduling, whether or not we want to do anything with that now or not, but some scheduling stuff. That should be about it. So I guess that concludes this portion of the training.